This is an example of proof by induction. The formula for the sum of the first n cubes can be found in the information for candidate's booklet and is given as n squared into n plus 1 all squared all over 4. The first stage of the proof is to check that it works. The left hand side, which is this, is simply a list of the first n cubes, the first cube. It's worth 1. The right hand side here is the formula. It's 1 squared times 2 squared over 4. That's equal to 1 as well. Mathematically, that's all you need, but you may also emotionally need to check a few more terms. If I had n is equal to 2, the left hand side would be the list, 1 cubed plus 2 cubed. That would be 1 plus 8, 9. The right hand side would be the formula, and that would be 2 squared times 3 squared over 4. That would be equal to 9 as well. It can be easily seen that this formula does work for the first few terms. The second stage in any proof by induction is to look at the internal consistency of the formula. Does Sn plus mu n plus 1 equal Sn plus 1? Does the sum of the first n terms plus the next term give us the next sum? We are assuming that this formula is now correct because it's worked on the first few terms. The next term is n plus 1 cubed. Adding these should get this formula. And what's happened here is I've taken n and replaced it with n plus 1, so my n squared becomes n plus 1 squared, and my n plus 1 squared becomes n plus 2 squared. Right, let's do the addition. Our first problem is a fraction on one side, and we can get that around that very easily by multiplying by 4 over 4. The next problem is I don't want to be involved with n to the power 4. That's quite difficult algebra. So I look for common factors. The common factors I've got are n plus 1 squared over 4. Let's factorise out. I've got n plus 1 squared over 4, that's just n squared. And I've got 4 lots of n plus 1. This part of the formula, my n plus 1 squared over 4, is exactly what I'm looking for. The remainder of the formula is going to be n squared plus 4n plus 4. Now I need to factorise this, and obviously my target is there. And that's exactly the result I wanted. So I've completed my proof. I've shown that this formula works when n is 1 and perhaps 2, perhaps 3. I've also shown that if my formula works when s is equal for n, it will work when s is equal to n plus 1. Yeah, that's the end of the proof. Come on, baby.